Hello everyone, in this video we will understand how to calculate the wind topography factor K3 as per IS 875 Part 3 2015. Now, in one previous video I have discussed how to calculate the design wind pressure PD, and for calculating the value of PD we need the value of Vz, which is actually the velocity at a particular height z. Now Vz can be calculated using this particular equation. Vz equals to Vb into K1 into K2 into K3 into K4. And in that video I have also discussed that when the ground slope, if this is the ground slope, if the ground slope is less than 3 degree, then the value of K3 will be 1. So if the ground slope is very close to horizontal ground, at that time it will be the K3 value will be 1. But if it is not 3 degree, not less than 3 degree, if it is some higher value, at that time we have to modify the value of K3, and it will be at that time it will be some higher value. And in that video also I have also discussed that K1, K2, K3, K and K4 all are actually amplifying factor. This value will actually increase the value of Vb to Vz. Normally these values are actually greater than 1. Now if our ground slope, for a particular condition, if our ground slope is greater than 3 degree, at that time the value of K3 will be greater than 1. Now how to calculate the value of K3? How to calculate the value of K3, that we will get from Annex C of IS 875 Part 3. Now in Annex C you will see actually there are some equations, and these equations are actually required for calculating the value of K3. Now K3 depends on this particular equations and tables, and from this particular values we can actually get the value of K3. Now for calculating the value of K3, the equation of K3 is 1 plus C into S0. Now what is C? We can calculate the value of C from this particular table. This is not table, only two values are there. If the value of theta s, what is theta s? Theta s is the upwind slope in the wind direction. So if there is one particular slope like this, then this will be theta s. And L is the actual length of the upwind slope in the wind direction. That means if suppose there is a slope like this and this is the top portion, this is the top portion, then this length will be L. L is the actual length of the upwind slope in the wind direction. Theta s is the upwind slope in the wind direction. And Z is the effective height of the topographic feature. So Z will be this particular value, this will be Z, the effective height of the topographic feature. This will be Z. So actually we can say tan theta s equals to Z by L. Tan theta s equals to Z by L. So if theta s is in between 3 to 17 degree, at that time C will be equals to 1.2 into Z by L. Z by L. And if theta s is greater than 17 degree, at that time C will be equals to 0.36. Now what is Z by L? Z by L is actually tan theta s. Tan theta s. So when our slope angle will actually change from 3 degree to 17 degree, the value of C will actually change in proportion with tan theta s, because Z by L is actually tan theta s. So C is 1.2 into tan theta s. Now for 17 degree if we think, tan 17 degree equals to 0.3. So 1.2 into 0.3 will be 0.36. So actually for theta is greater than 17 degree, we will consider the value of tan 17 degree, and at that time the value will be 0.36. So up to 17 degree, the value of C will increase proportionally, 1.2 into tan theta s, and for 17 degree it will achieve the maximum value. And after that the value of C will remain constant and it will be 0.36. So C value, we understand that C is actually proportional to the tan theta. Tan theta is the upwind slope. Upwind slope. So this is C. And what is S0? S0 is one particular factor which depends on three different factors. One is H, one is X, and another is LE. Now what is H and X? Suppose there is one particular building. Suppose there is one particular building in this location. Then H will be the height of this particular building. This will be H. This will be H. And X will be the distance of the building from the center line of the topographic feature. From this particular position, from the center line of the topographic feature, or we can say that from the ridge line. If this is our hill and this is the maximum height of the topographic feature, then we will consider the value of X from this maximum height. We will consider the value of X from this maximum height. And H is the height of the building. So H and X we know. Another thing is LE, which is very important. LE is very important. LE is actually the effective horizontal length. Effective horizontal length of the hill depending on the slope as indicated below. Now if our ground slope is in between 3 to 17 degree, at that time LE will be equals to L. If ground slope is greater than 17 degree, then LE will be Z by 0.3. Z by 0.3. And if it is less than 3 degree, then actually no calculation is required. If our theta s is less than 3 degree, then actually we know that K3 equals to 1. And at that time no calculation is required. So two particular cases we have to remember. One is when the theta s is in between 3 to 17 degree. At that time LU will be equals to L. And when theta s is greater than 17 degree, at that time LU will be equals to Z by 0.3. And similarly, when the slope is in between 3 to 17 degree, at that time C will be equals to 1.2 into Z by L. And theta s, and if theta s is greater than 17 degree, at that time C will be equals to 0.36. So these two cases we have to remember. And one thing is also very important. The influence of the topographic feature is considered to extend 1.5 LE in the upwind direction and 2.5 LE in the downwind direction of the summit of crest. So we can say that suppose if this is one topographic feature, then the effect of topographic feature will be 1.5 LE in the upwind direction and 2.5 LE in the downwind direction from the maximum height of the topographic feature. From this particular line, if we think in the upwind and downwind direction, at that time this will be the influence of the topographic feature when wind is coming from this side. Because when wind is coming from this side, at that time this will be the upwind slope and this will be the downwind slope. And this particular angle will be theta s, not this one. So this is theta s. So now again, if we look for this picture, here wind is coming from this direction. This is the direction of wind. This is the upwind slope and this is the downwind slope. So region affected by topographic feature, the region will be 1.5 LE in the upwind direction. This is 1.5 LE and it will be 2.5 LE in the downwind direction. And as I have already said that if this is one hill, and if one particular building is located in that particular position, then this is Z, the maximum height of the topographic feature. This value will be H. Here you can see this is H. So our building is in this particular position. This is H. And the distance of this building from the maximum height of the topographic feature from this line, this value will be X. This is theta s. This is theta s. And this is L. This is L. L is the length in the upwind direction. So tan theta s equals to Z by L. And two particular conditions we have to remember. One is hill or ridge. Hill or ridge, when it will hill or ridge, when the downwind slope is greater than 3 degree. When the downwind slope is greater than 3 degree, at that time it will be hill or ridge. And when the downwind slope is less than 3 degree, like this, at that time we will say that is cliff or escarpment. So this will be cliff or escarpment if the downwind slope is less than 3 degree. Now for two different cases, like for ridge and hill, we will use this particular chart for calculating the value of S0. Now I already mentioned that S0 depends on three factors. One is H, LE and X. And here factors required are actually H by LE and X by LE. Now for a particular building, for a particular slope, if the building is located in this particular position, we will consider the value of X as negative. Here X will be negative. And if another building located in this particular position, at that time this will be X and this X will be positive. So in upwind direction it will be negative and in downwind direction it will be positive. And we already know that the effect of topography will be 1.5 LE in the upwind direction and 2.5 LE in the downwind direction. So here also you can see that the value is from minus 1.5 to 2.5. Here it is 0. So if any building is located at this particular position, here for this building the X will be 0. Otherwise we have to consider the appropriate value of X. And H is the height of the building. H is the height of the building. Now this particular figure, the left one is for ridge and hill. For ridge and hill, we will consider this particular plot. When it is for cliff or escarpment, at that time we will consider this particular figure. So if I say again, the equation of K3 is what? The equation of K3 is K3 equals to 1 plus C into S0. Now C we can calculate from that table I have mentioned before. And S0 depends on what? S0 depends on H by LE, X by LE, and from H by LE and X by LE we can calculate the value of S0. And C depends on what? C depends on the tan theta s. Tan theta s, like 1.2 into tan theta s is actually C, or we can say 1.2 into Z by L. When the value of theta s is less than 17 degree, at that time the equation will be 1.2 into Z by L. When it will be more than 17 degree, it will be 0.36. So if we know the value of Z and L and also theta s, because theta s will give us the understanding that which equation we have to use. So all these values are actually required. We need the value of H, X, LE, Z, L, theta s. All these values are actually required for calculating the value of K3. So again, if I repeat, LE is the effective length of the topographic feature. If the ground slope is in between 3 to 17 degree, then LE will be equals to L. And if the ground slope is greater than 17 degree, at that time LE will be equals to Z by 0.3. Now the influence of topographic feature will be 1.5 LE in the upwind direction and 2.5 LE in the downwind direction. And the equation of K3 is 1 plus C into S0. 1 plus C into S0, where what is C? C, I have already mentioned that C depends on the tan value of slope. So if the slope is in between 3 to 17 degree, the value of C will be 1.2 into Z by L. And if the slope is greater than 17 degree, then Z by L will be For greater than 17 degree, we will consider the value of tan 17 degree. So tan 17 degree is 0.3. So it will be 1.2 into 0.3. So it will be 0.36. So the equation of K3 is K3 equals to 1 plus C into S0. If we go for a particular problem, here you can see this is one particular building. This length is L. This length is L. We have to calculate the value of LE. We have to calculate the value of LE. Now here our upwind ground slope is 30 degree. If wind is coming from left, then this will be the upwind slope and this will be the downwind slope. But our building is actually locating at the top portion of the topographic feature, which is crest. So here this is the position of our building. So for our building, x will be 0. X is the distance from the crest point. Here this distance will be x, this or this. Along the upwind slope it will be negative. Along the downwind slope it will be positive. So for our building x is 0. What is h? H is 30 meter. What is z? Z is also 30 meter. Here x equals to, z equals to h, because our building is locating at the topmost portion of the topographic feature. Now, what will be the value of LE, effective length? LE will be equals to, for our problem, it will be Z by 0.3, because our ground slope is greater than 17 degree. So LE will be equals to Z by 0.3. So what is Z? Z is 30. So 30 by 0.3, it will be 100 meter. Now we know the value of LE. Now we have to calculate the value of C and S0. C and S0 we have to calculate. Now what will be the value of C? C will be 0.36. Because our theta S is 30 degree. So it is greater than 17 degree. So C will be 0.36. Now we have to calculate the value of S0. Next task is we have to calculate the value of S0. And we know that S0 depends on two factors. One is x by LE and another is h by LE. So S0 depends on two factors. One is x by LE, another is h by LE. Now what is the value of x by LE for our problem? X is 0. So it will be 0. And h by LE will be, h is 30 meter and LE is 100. So it will be 0.3. So h by LE is 0.3, x by LE is 0. So by using this particular chart, we can get the value of S0. So our h by LE is 0.3. So this will be the line of 0.3 and our x by LE is 0. So our S0 will be in this particular point. This point is in between 0.4 to 0.6, but it is very close to 0.6. So we can consider that S0 is 0.55. So now what will be the value of our K3? K3 is 1 plus C into S0. So our C is 0.36 and S0 is 0.55. So it will be 1 plus 0.36 and 0.55. So it will be 1.198. So if our wind is coming from left, then our K3 value will be 1.198. 1.198. Now what we have to do if the wind is coming from right, not from left, if the wind is coming from right. For previous problem, when the wind is coming from left, K3 value was 1.198. Now what will happen if the wind is coming from right? When wind will come from right, at that time the slope will also change. Because now the upwind slope will be this and this will be the downwind slope. So upwind and downwind slope has changed and here our theta s will be 15 degree, which is less than 17 degree. So all the equation will actually change. All the equations will actually change. Now this particular length will be L. Our Z is again 30 meter. Z 30 meter. L is also 30 meter, H is also 30 meter, and X is 0 because the building is locating at the crest position. So X is 0, Z is 30 meter, H is 30 meter. And what will be L? For that we can use this equation, tan theta s equals to Z by L. So L will be Z by tan theta s. Z is 30 meter, so L will be 30 by tan 15 degree. So it will be 111.96 meter. 111.96 meter. So L is 111.96 meter, and when the ground slope is in between 3 to 17 degree, at that time LE will be equals to L. So LE will be also equals to 111.96 meter. So this is the value of LE. And what will be the value of C? C will be 1.2 into Z by L. So Z is how much? Z is 30 meter. So it will be 1.2 into 30 by 111.96. So it will be close to 0.321. So this is the value of C, 0.321. Now our LE is 111.96. LE is 111.96. C is 0.321. For calculating the value of S0, we need the value of H by LE and X by LE. X by L is 0 because here for this building the X is 0. So what is H by LE? H equals to 30 and LE equals to 111.96. 30 by 111.96, which is actually the length. So it will be equals to 0.267. This is actually very similar to tan 15 degree because tan 15 degree is also 30 by L. 30 by L. And H by LE is also 30 by L because L is LE. For this particular problem, L is LE. So this is also tan 15 degree. So for this problem, H by LE is 0.267, C is 0.321, and LE is 111.96 meter. So our what is the value of S0? For that again we can use this particular chart. Now here you can see that if our H by LE is 0.267, which will be close to this. So if we draw one horizontal line like this, we can draw in both the upwind and downwind direction, because now this time our building is located at the crest position. So this will be the point. This will be the point. And this point is very close to 0.6 because X is 0. So X will be 0 and H by LE is 0.267. H by LE is 0.267. So the value of S0 will be 0.6. So S0 is 0.6. So what will be K3? K3 will be equals to 1 plus C into S0, where C is 0.321 and S0 is 0.6. So what will be K3? K3 will be 1 plus C, C is 0.321 into 0.6. So it will be 1.193. So when the wind is coming from left, at that time K3 will be 1.198, and when the wind is coming from right, at that time K3 will be 1.193. So actually we can use both this value. If we are considering this building and we are considering the wind angle as 0 degree, at that time we can consider the value of 1.198. And when the wind is coming from right, when we are considering the wind angle is 180 degree, we can consider the value of K3 as 1.193. We can consider these two different values for different case. When we are doing the wind calculation, when the wind is coming from 0 degree, we can consider the value 1.198. When we are considering the value of 180 degree, we can consider the value of 1.193. Or we can consider the maximum value. If we are doing all this calculation in our hand, at that time we can consider the maximum value. and at that time we can consider this particular value 1.198. Now the previous problem was when the building is located at the crest position, but it may also happen that the building is locating in the slope itself, either in the upwind position or in the downwind position. If wind is coming from this side, this will be the upwind slope, this will be the downwind slope. So our building can actually locate in any particular position. So at that time also we have to calculate the value of K3. Now suppose for this problem, if wind is coming from left, then this will be the upwind slope and this will be the downwind slope. The upwind slope is 30 degree and downwind slope is, this is 10 degree. And the Z value is 50 meter. The height of the topographic feature, this is 50 meter. Z equals to 50 meter. And for our building, H equals to 30 meter. H equals to 30 meter. So what is X? X is actually the distance between these two lines. This will be X, because we know that X is actually the distance of the point from the topmost point of the topographic feature. So if we think this as the crest line, from this line how much is the value of, how much is the distance of our building, that will be X. So how to calculate the value of X? This is 30 meter, H is 30 meter, and here our Z is 50 meter. So this value, this value will be 20 meter. So by using the simple logic of trigonometry, we can calculate that X will be equals to, we can first calculate 20 by X equals to tan 30 degree. 20 by X equals to tan 30 degree. So X will be equals to, from this X will be equals to 20 by tan 30 degree. 20 by tan 30 degree, it will be equals to close to 34.64 meter. 34.64 meter. So this will be the value of X. Now 34.64 meter, H is 30 meter. So now first let us calculate the value of LE. How much will be LE when wind is coming from left? When wind is coming from left, theta S is 30 degree. So if it is 30 degree, it will be greater than 17 degree. So LE will be equals to Z by 0.3. Z by 0.3, and Z is how much? Z is 50 meter. Z is 50 meter. So 50 by 0.3. So it is close to 166.67 meter. So LE for our problem is 166.67 meter. Z by 0.3. And how much will be C? Our ground slope is greater than 17 degree. So our C will be 0.36. So C will be 0.36. Now we have to calculate the value of H by LE and X by LE. So how much will be H by LE? H by LE will be 30 by 166.67. So it is close to 0.18. And X by LE is actually 34.64 X by 166.67. So it will be 0.21. So H by LE is 0.18, X by LE is 0.21, and by using this particular chart, we can calculate the value of S0. Now we know that when we are considering our building along the upwind direction, the X value will be negative, and in the downwind direction, X will be positive. So our X by LE, this particular 0.21 is actually minus 0.21. So H by LE is 0.18 and X by LE is minus 0.21. Negative value, because this is along the upwind direction. So if we just take the value of H by LE 0.18, this will be 0.18 line, this line, and this is X by LE. This is X by LE is how much? 0.21, minus 0.21. So this two line is cutting in this particular point, in this particular point, it is in between 0.6 and 0.8. This particular two lines are cutting in this point. This is in between the line of 0.6 and 0.8. So our S0 will be 0.7 and C is 0.36. So what will be K3? K3 will be equals to 1 plus C into S0. So C is 0.36 and S0 is 0.7. So it will be 1.252. 1.252. So K3 is 1.252 when wind is coming from left. When wind is coming from left, K3 will be 1.252. So K3 is 1.252 when the wind is coming from left. Now what will happen if the wind is coming from right? If the wind is coming from this direction? At that time, our building will be in the downwind slope. Not like the previous problem. Now it will be in the downwind slope and some equation will actually change. Now here actually if we look for this particular case, here our ground slope is 10 degree. So 10 degree means our slope is in between 3 and 17 degree. So LE will be equals to L. So first we have to calculate the value of L. Now this will be L. This will be L. If we continue this figure, this will be L. So actually 50 by L will be tan 10 degree. Or L will be equals to L will be equals to 50 by tan 10 degree. 50 by L equals to tan 10 degree. So L will be equals to 50 by tan 10 degree and it will be close to 283.56 meter. So L equals to 283.56 meter. And when we know that when the ground slope is in between 3 to 17 degree, at that time LE will be equals to L. So LE will be also 283.56 meter. 283.56 meter. So this will be LE. So LE will be 283.56 meter. Now we have to calculate the value of C. C will be how much? When the ground slope is in between 3 to 17 degree, C will be 1.2 into Z by L. So 1.2 into how much is Z? Z is this particular height of the topographic feature, which is 50 meter. So Z will be 50 meter. What is H? H for this building? H will be 30 meter. And what will be X? X is the distance of our building from the crest line. So this will be X. And in previous problem also we have calculated the value of X. X is how much? Tan 30 degree equals to this particular length. This length is total is 50. This is 30. So this length will be 20. If we think for this triangle, the height of that triangle will be 20 and this is X. So tan 30 degree equals to height, which is 20 by X. So X will be 20 by tan 30, which will be 34.64. So X will be 34.64. X will be 34.64. So our H by LE will be how much? H by LE will be 30 by 283.56 and X by LE will be 34.64 by 283.56. And how much will be our C? C will be 1.2 into Z by L. So Z is 50 and L is 283.56. So 1.2 into 50 by 283.56, this is close to 0.2116. And H by LE is 30 by 283.56, this is 0.106. And X by LE is 34.64 by 283.56, this will be 0.122. So h by LE is 0.106 and x by LE will be 0.122. Now our x by LE will be positive because now our building is locating on the downwind slope because wind is coming from right and our building is in the downwind slope. So now our x by LE will be positive. So our h by LE is 0.106 and x by LE is how much? X by LE is 0.122. So these two values are lines are cutting in this particular point, and this is actually in between these two lines, the value of 1 and 0.8. For this line, the value of S0 is 0.8. So our value is in between 1 and 0.8. So we can consider that for our case S0 equals to 0.9. So now how much will be K3? K3 will be equals to 1 plus C into S0. So C is how much? We have calculated C. C is 0.2116. So it will be 1 plus 0.2116 into S0. S0 we have calculated 0.9. So the value of K3 will be equals to 1.19. So if the wind comes from left, at that time we can consider the value of K3 as 1.252, and when the wind is coming from right, at that time we can consider the value of K3 as 1.19. Actually, for two different cases, if we consider both these cases separately, then we can consider the value of K3 as separate value for doing all our calculation, like when we are calculating the value of PD. At that time, when we will consider the wind angle 0 degree, at that time we will use the value of K3 as 1.252, and when the wind angle will be 180 degree, at that time we will consider the value of K3 as 1.19. But for normally we can, if we are doing one calculation and the calculation is very simple, we are doing one hand calculation, at that time it will be good if we consider the value of higher one. That means K3 equals to 1.252. We can consider this particular value for doing all our problem. Then it is also okay. But we can consider these two separate value also, like 1.252 and 1.19. These two value we can also consider separately. If we consider separate calculation for two different wind direction, it will be also okay. So now this is one problem of cliff or escarpment when the downwind slope is less than 3 degree. When the downwind slope is less than 3 degree, at that time it will be cliff or escarpments. So now suppose the wind is coming from left like this, and this will be our ground slope, upwind ground slope. This is theta s. So theta s equals to 30 degree. So now also the problem is very same like the previous problems. If our building is locating in this particular position, the crest point, here actually our building is locating here. So here actually x will be equals to 0. And z will be how much? Z will be 30 meter, the maximum height of the topographic feature. And h will be also equals to 30 meter. Z and h both will be equals to 30 meter. So what will be our L? L will be L or LE. At that time we have to calculate the value like this: tan 30 degree equals to 30 by L, or L equals to 30 by tan 30 degree. 30 by tan 30 degree. So in that way we can calculate the value of L. Now here actually for our problem, the ground slope is greater than 17 degree. Ground slope is greater than 17 degree. So LE is not L, LE is Z by 0.3. So our problem LE is Z by 0.3. So LE will be equals to, Z is how much? Z is 30 meter, 30 by 0.3. So it will be 100 meter. So LE will be 100 meter. And for calculating the value of C, as ground slope is greater than 17 degree, our is 30 degree. So C will be 0.36. So C is 0.36, L is 100 meter, and H is 30 meter. X is 0. X is 0. So how much will be H by LE? H by LE will be 30 by 100. So it will be 0.3. So H by LE is 0.3. C is 0.36. We have to calculate the value of S0 if we want to know the value of K3. So how much will be S0? Here actually you can see that for this line, H by LE is 0.3. So for this line, H by LE is 0.3 for this line, and X is 0, so this line. So here actually our value of S0 will be close to 0.6, so it is 0.55. So S0 is 0.55 and C is 0.36. So what will be K3? K3 will be equals to 1 plus C into S0. So 1 plus 0.36 into 0.55. So it will be 1.198. Like the first problem, this value of K3 is also same, 1.198. So when the wind is coming from left, K3 will be 1.198. K3 will be 1.198. Now here our building is actually locating at the top point of the crest. But suppose for a different problem, our building is locating in this particular position. Then what we have to do? Here also the calculation will be very same. We have to take this value as H and this as X, and taking these two value from this particular left side of the chart, by taking one value of H by LE and X by LE, we can get the particular value of S0. From this point, we will get the value of X0. Now in the upwind slope, we know that this is the upwind slope where X is negative, here X will be negative. And if one particular building is located in the downwind slope like this, if the building is located at the downwind slope, at that time this will be H. And here you can easily say that H will be very close to 30 meter because the downwind slope is less than 3 degree. So these two height will be almost same, will be almost close to 30 meter. And this particular value will be X. And here it will be positive. In this position it will be negative. Here it will be positive. So now by using the value of H by LE and X by LE, we can also get the value of appropriate value of H by LE and X by LE. We can also get the value of S0 in the downwind slope also. Like here for a particular line, if two values are known to us, by thinking a curve in between curve like this, we will get the appropriate value of S0. So it is very simple and similar to the previous problem, and we can easily calculate the value of S0. And when we will calculate the value of S0, by using this particular equation, we can calculate the value of K3. So this calculation is actually very simple. Just by using these two table, and these charts, we can actually calculate the value of K3 for different condition. Now one can also ask that what will happen if the wind is coming from right direction. Our building is locating in this particular position and wind is coming from right. At that time actually we do not have to calculate the value of K3, because we know that we have to calculate the value of K3 when the ground slope is greater than 3 degree. But for one cliff or escarpment, actually this ground slope is actually less than 3 degree. So here if wind is coming from right, at that time there is no need to calculate the value of K3. K3 will be simply 1. If the wind is coming from left like this, at that time we have to calculate the value of K3. But if wind is coming from right, as the ground slope is less than 3 degree from right, at that time K3 will be simply 1. From left it is 1.198, from right it will be 1. And in that way we can actually calculate the value of K3 for any problem, for any condition. Just by using these equations we can calculate the value of K3. So I hope you have able to understand that how to calculate the value of K3 for different conditions. These calculations are very simple, but still if you have any type of problem, you may ask the question in the comment box. And I have prepared some other videos related to wind load calculation that you will get in the description box and also in the I button above. Now this is all from today's video. Hope you have able to understand all this thing, that how to calculate the value of K3. So thank you for your attention. Thank you.